A company manufactures two models of MP3 players. Let X represent the number in millions of the first model made, and let Y represent the number in millions of the second model made. The company's revenue can be modeled by the equation R of X, Y. We first want to find the marginal revenue equations, which should be the first order partial derivatives. So to find the partial derivative of R with respect to X, we'll differentiate with respect to R, treating Y as a constant. The derivative of 140x with respect to x would be 140, plus the derivative of 50y with respect to x would be 0, since we're treating y as a constant, minus the derivative of 4x squared with respect to x, that would be minus 8x, and then minus the derivative of 2y squared with respect to x would be 0, and then minus the derivative of xy with respect to x, that would be minus y. And now for the partial derivative with respect to y, we'll differentiate with respect to y, treating x as a constant. And therefore, the derivative of 140x with respect to y would be 0, plus the derivative of 50y with respect to y, that'd be 50, minus the derivative of 4x squared with respect to y would be 0, minus the derivative of 2y squared with respect to y, that would be minus 4y, and then minus the derivative of xy with respect to y would be minus x. So here's the first part of our question. For the second part, we can achieve maximum revenue when both partial derivatives are equal to 0. So we want to set our partial derivatives equal to 0 and solve as a system of equations to find the production levels that will maximize revenue. So here are the partial derivatives from the first slide. Notice how I set them equal to 0, and now we'll solve this as a system. So to solve this system, let's use substitution. Let's go ahead and solve this first equation here for y. Notice if we add y to both sides of the equation, we could write this as y equals 140 minus 8x. So now we'll substitute 140 minus 8x for y in the second equation, and then solve for x. So making this substitution, we would have 50 minus 4 times the quantity 140 minus 8x, and then minus x equals 0. Let's clear the parentheses and solve for x. So we'd have 50, this would be minus 560 plus 32x minus x equals 0. So combining like terms, we have negative 510 plus 31x equals 0. Add 510 to both sides, that would give us 31x equals 510. Divide by 31. So the exact value of x that would maximize revenue is 510 divided by 31. Let's go ahead and write that here. But let's also get a decimal approximation, because remember, this represents the production level in millions of MP3 players. So 510 divided by 31, if we round to 4 decimal places, this would be approximately 16.4516. Notice in this form we can tell that the production level is approximately 16.4516 million iPods for Model 1. And then to find the production level for the second model, we'll determine y, where y is going to be equal to 140 minus 8 times the exact value of 510 divided by 31. So we'll get the exact value, and then we'll get a decimal approximation. So here's the decimal approximation. If we press math, enter, enter, we can get the exact value of 260 divided by 31. Well, the decimal approximation to 4 decimal places would be approximately 8.3871. So again, the exact value would be 260 divided by 31, which is what we should enter. But to better understand this, it's approximately 8.3871. And again, these are the production levels in millions of iPods. I hope you found this helpful.